what are the important topics related to this nucleophilic substitution reaction. So, nucleophilic substitution reaction means when the nucleophile or electron rich species, that is, the electron rich species, attacks at the part of substrate molecule which is electron deficient. So, the nucleophile, which is the electron rich species, attacks the particle which is electron deficient. For example, OH, which is the electron rich species, will attack the nucleophile which is electron deficient. And if this happens, then this reaction is called as a nucleophilic substitution reaction, where the nucleophile replaces the substituent group. Okay, so this is very important, or replaces the already existing nucleophile in a molecule. That means the one which is being replaced by the nucleophile is also a nucleophile. So the nucleophilic reaction is the reaction in which a nucleophile attacks the reactant molecule which is having itself a substrate group which is itself having the nucleophile. That means one nucleophile is replaced with the another nucleophile. That is called as the nucleophilic reaction, substitution reaction. That means one nucleophile attacks the another nucleophile. So haloalkanes are the substrate in these reactions. So what is the substrate in the nucleophilic substitution reaction? They are the haloalkanes. So there, in this diagram you can see that haloalkanes are the nucleophiles here, and it is being replaced by the nucleophile. So there are in this type of reaction, nucleophile reacts with haloalkane and having the partial positive and charge and the partial negative charge. The nucleophile which is attached to the substrate, that means methyl group, the methyl group has the partial positive charge, and the nucleophile is having the partial negative charge. And in this case, this X is the halogen. That is, a halogen is partial positive charge on the carbon atom bonded to the halogen. So when this carbon atom is bonded to the halogen, that means it is having the partial positive charge. A substitution reaction takes place. A substitution reaction takes place, and the halogen atom called leaving group departs as halide ion. When the substitution reaction takes place, this leaving group, which is the halogen atom, it departs, it leaves this mm, uh, substrate, and it becomes the halide ion. Hence, since the substitution reaction is initiated by the nucleophile, and it is called a nucleophilic substitution reaction. Since this is called as just nucleophilic substitution reaction. So it is very easy. What is nucleophilic substitution reaction? When which one nucleophile replaces the another nucleophile, and when one nucleophile replaces the another nucleophile, the leaving nucleophile is called as a halide ion, or it is having the negative charge. Please like and share this video, because if you will like this video and share this video, it will reach to the other people. And I am trying to make it very easy for you, because most of the NEET exams it is being asked there, and people I was just early in the morning, one of the student was he with talking to me, and he said I found it very difficult. So I said, let me give some lecture on it, and you should watch that lecture, and it is for that person also, as well as the other people who are finding it very difficult. So if one of the most useful class of organic reaction is alkyl halides, in which halogen is bonded to sp3 hybridized atom. This is very important point. Here the alkyl halide is bonded to carbon, which is sp3 hybridized carbon. It is bonded to sp3 hybridized carbon. Most of the time this question is asked, the halogen is bonded to what type of carbon, and it is sp3 hybridized carbon. The product formed by this reaction is haloalkane, and some common nucleophiles are in the table. So if you are confused about what are the nucleophile, so the substrate products are also written here. You must go through them. That NaOH, KOH, they give the OH as a nucleophile. Water is also the nucleophile. NaOR, OR is also the nucleophile. NaI, that is iodide is also nucleophile. And ammonia is also the nucleophile. And the substrate products with R and It gives class of the main product is alcohol, ether, alkyl halide, secondary amines, tertiary amines, isonitrile, and go this table and you will understand LiH LiAH4 where the halide is hydride ion is formed and it forms a hydrocarbon. So now the group like cyanides, nitrates possess two nucleophilic centers. This is very important point, and you must understand what are the ambient nucleophiles. Those nucleophiles which are having the two nucleophilic centers. For example, if you will see in this reaction C triple bond N, and when you will see that there is a shift of the electron pair on the C and the negative charge on the N. So sometimes C can act as a nucleophile, and other times C double bond N negative can act as the nucleophile. So this is actually these are called as the ambient nucleophile. So if sometimes in the exam there will be a small question that which of the following is ambient nucleotide. So this is the example of ambient nucleotide. Now, moving ahead, we will say haloalkanes react with the HCN form the alkyl halide and the product, while HGCN forms isocyanates as a chief product. Explain why this is happening. This is the question. That is, HCN is predominantly ionic and provide a cyanide ion in a solution. Although both carbon and nitrogen are in the position to donate electron pair, that means the both are in the position to donate the electron pair, and the attack takes place mainly through carbon atom and not through the nitrogen atom, since carbon carbon double bond single bond is more stable than carbon nitrogen bond. So however, AgCN is mainly covalent in nature and nitrogen is free to donate electron pair, forming isocyanide as the main product. This is very important point, that if these ambient nucleotides are having this negative charge, and they can also act as a nucleophile in the form of C and NC. C can act as a nucleophile, N can act as a nucleophile, but when they go in the form of reaction and form the alkyl cyanides, the main product, while is AgCN forms isocyanides as the chief product. Why they formed as a isocyanidus as a chief product? Because C takes place in the reaction. Now, similarly, nitrite ion also represents an ambient nucleotide, like the HCN that acts as the ambient nucleophile. In the same way, nitrite ion also forms as a nucleophile. The linkage through this oxygen react results in alkyl nitrate, while though through the nitrogen atom it leads to nitroalkanes. It can form alkyl nitrate, and if the nitrogen takes part in the reaction, it can lead to the nitroalkanes. Now, what is the mechanism of this nucleophilic substitution reaction? Very important point. What is the mechanism? The mechanism is the reaction between CH3Cl, that means methyl chloride and hydroxide ion to yield to ethanol. Take this example of this reaction. This is SN2, that is substitution nucleophile binuclear, and the reaction depends upon the concentration of the both reactants. Now, this is very interesting here to understand what is SN2 and what is SN1. SN2, because the both the substrates, the reaction or the order of their reaction depends upon the both of the substrates, and that is why it is called as the second order reaction or second order kinetic reaction. And SN1, that is called as the first order kinetic reaction. Mainly only the kinetics of the reaction depends upon the one substrate. Now take this example. This is methyl chloride, and for example, we have added the NaOH in it, Na positive, OH negative. Now this OH negative comes and interacts with this methyl chloride. There is no bonding. This is just the interaction, that it's coming very close to the methyl chloride, and there happens this strange thing, and this strange thing is very very fast, and you will not get in any intermediary product. And when you will not get any intermediary product, that means it is for this fraction of second, or it is for the small time, or it is just that somebody comes in and somebody goes outside. For example, you might have seen the cartoons or the comedy of that a famous non-speaking actor. When he somebody policeman is running behind him, he goes from one side of the door, and the door is open on the both sides. They can shift the door. When policeman enters on the one side, he leaves on the neck on the other side of the room, and this process continues. In the same way, when OH comes, it comes and forms interaction with methyl group, and it finds a space when if it is primary methyl chloride, and it is primary halide, alkyl halide, then it's very easy for them because the steric hindrance is less, and you can see this is coming and forming the interaction. When this starts forming the bond with this central carbon atom, this halide leaves as Cl negative. So this is very important. It depicts the bimolecular nucleophilic substitution reaction. The incoming nucleophile interacts. This is very important. It interacts with alkyl halide, causing carbon halide bond to break, and new bond is formed between the carbon and attacking nucleophile. When it comes and starts interacting, that means they just started making the bond. It causes the breakage of one bond, and other bond leaves. In here, it is the carbon oxygen bond formed between the C and OH, and these processes take place simultaneously, and these processes take place simultaneously. So this is very important in a single step, and no intermediate is formed. So there is no intermediate bond formation as the reaction progresses, and the bond between the incoming nucleophile and carbon atom starts forming. As the bond becomes starts forming, and the bond becomes between the both atoms and leaving group weakness. When the bond starts forming, the carbon atom starts forming the bond between carbon atom and the leaving group starts breaking yet weakening, and it breaks away. As this happens, the three carbon hydrogen bonds of the substrate starting moving away from the attacking nucleophile. That means the three carbon hydrogen bonds of this substrate. Carbon hydrogen bonds, there are three carbon hydrogen bonds. Three carbon hydrogen bonds you can see in this diagram. What is being said that they starts moving away from the attacking nucleophile, and in the transition state all the three CH bonds are in the same plane, and the attacking and leaving nucleophile are partially attached to the carbon. That means the leaving group and the attaching group, they are partially attached to the carbon. And here you can see that the valency of the carbon is it is attached to the five bonds. How is it possible? Oh my god, this is the exceptional case where the C is attached to the five bonds. As attacking nucleophile approaches closer to the carbon, when it comes closer to the carbon, CH bond still keeps on moving in the same direction till the attacking nucleophile to the carbon, and this leaving the group leaves the and leaving group leaves the carbon, and the CH bond keeps moving in the same direction. They start moving in the same direction till the attacking nucleophile attaches to the carbon and leaving group leaves to the carbon. So as a result, configuration is inverted. Now this is very important point. What is being said here? That there is a movement of CH bonds, and there is a movement of this CH bonds until the nucleophile comes and other nucleophile leaves, and the configuration is inverted. What does it mean? That means this is the inversion reaction. This is not the retention reaction where the bonds are fixed. Any nucleophile comes and gets attached to the carbon, still hydrogen and carbon bonds are not moving anywhere, they are remaining there. But after this reaction happens, there is inversion, and the configuration of the carbon atom under attack inverts in much the same way as umbrella is turned inside out when caught in the strong wind. This is very important. That means the configuration of this structure, this carbon attached to the hydrogens is getting inverted. That means it gets in the opposite side. For example, the umbrella, which is whose spikes are downwards, when the wind comes and they go upwards, and this changes the direction, and this process is called the inversion of the configuration. So you must remember that in SN2, in SN2 nucleophilic substitution reaction, there is inversion of the configuration, and in this transition state the carbon atom is simultaneously bonded to the incoming nucleophile and outgoing group. Such substrates are unstable, cannot be isolated, and thus in the transition state carbon is simultaneously bonded to the 5 atoms. Oh my god, this is very scary. This is very scary. That means carbon is attached simultaneously to 5 atoms. How is it possible? But it becomes possible here. So this is this configuration. That means the arrangement of functional groups around the carbon atom. What do you understand by the configuration? That means the arrangement of the groups around the carbon atom. And there are two structures of the same compound, and they differ in spatial arrangement of functional groups attached to the carbon. Structure A is the mirror image of the structure B. So we say configuration of the carbon in structure A is mirror image of the configuration of structure B. Now, since this reaction requires the approach of nucleophile to the carbon bearing the leaving group and the presence of bulky substituents on the near the carbon atom has a dramatic inhibiting effect. If simply it is alkyl halide, methyl halide reaction mostly is rapid in SN2 reaction, because there are only small hydrogen atoms, and the tertiary halides are least reactive because bulky group hinders the approaching. Now, if there are other bulky groups, for example, CH3 is attached and tertiary butyl group is there or isopropyl group is there, so with methyl group it is very easy, and the order of reactivity is primary halides. SN2 shows higher order of reactivity with the primary halides, then the secondary, then the tertiary. You can see that incoming nucleophile has to squeeze through these hydrogen atoms and these bulky groups to reach the central carbon. So this is all about the SN2 reaction. Now the SN1 reaction. SN1 reaction is carried in the polar protic solvent like water, alcohol, and acetic acid, which releases H positive. Okay, the reaction between the tertiary butyl bromide and hydroxide ion yields tertiary butyl alcohol. So there is the formation of alcohol, and they follows the order of kinetics. First order kinetics. That means it is depend upon the only on the substrate. If the concentration of substrate increases, then the rate of reaction is also increases, and the rate of reaction is dependent upon the one reactant, that is tertiary butyl. It has two steps. One step is the formation of the carbocation and release of bromide. After this step, there is another step that OH group comes and attacks the central carbon and forming the alcohol. Now, there is no inversion. There was a phone call from a friend, because there is a meeting after half an hour, so that's why he was calling me. Now, you can see Step one is the slowest step and reversible step. It involves CBr bond breaking, and for which the energy is obtained through the solvation of the halide ion and with the proton of the protic solvent. That is why there is acetic acid and water. Since the reaction depends upon the slowest step, the rate of reaction depends only on the concentration of alkyl halide, not the concentration of hydroxide ion. Further, greater the stability of carbocation, greater will be the ease of formation of alkyl halide, and faster will be the rate of reaction. This is very important, and it can come into the one line question, that greater will be the ease of formation of alkyl halide depends upon the greater the stability of carbon cation, and faster will be the reaction. They can also put the slower will be the reaction there. In case of alkyl halide, tertiary alkyl halides undergo tertiary alkyl halides undergo SN1 reaction and very fast because of the high stability of carbocation. So this is tertiary halides, then secondary halides and primary halides. That means the SN2 follows the opposite uh, sign of that, means tertiary halides are taking strongly taking part in the substitution reaction, then secondary, then primary. For the same reason, alkyl and benzyl halides show higher reactivity towards the SN1 reaction, and the carbocation thus formed gets stabilized through resonance. So this is all from SN1, SN2, very easy topic, and don't be afraid of this chemistry. Then in the next topic, I will tell you about the optical activity and molecular asymmetry. And in the next topic, please comment, because sir, make this video as soon as possible, and we will understand what is resmization and what are the rhythmic mixtures and what is retention and what is inversion. That's very important to understand. Okay, thank you for watching and sharing this video. Please watch and share this video with others. Thank you so much.